Okay, today we're going to slide up the shore from Knife River up to Two Harbors, 22 miles north of Duluth, to the lighthouse and to the bay. Today we're going to move on to nested for loops. This is one of these topics that looks easy, and then you realize pretty quickly that it's much more complicated than you expect. I'll try to walk through it slowly just so we get the idea. I won't ask about nested for loops on the exam coming up. That will be something that we'll do on exam 2. But you will have to know how to do this, so we'll go through it slowly. Imagine you want to draw a geometric shape using only asterisks, stars. How would you write code that would produce this type of output? You'd ask the user how many rows do you have, and it would produce 5 rows. The first row has no stars in it. The second has 1, the next has 2, the next has 3, the next has 4. So there's 5 rows total. If they said they wanted 9 rows, your program should produce 9. When I ask this on exams, sometimes I get this kind of output, a bunch of cout statements. And that's not what we're looking for. That solves one case of the problem, but it doesn't solve the general case, where the user can type in whatever positive number they want and the thing automatically produces that many. So we're going to have to do this using something else than just a bunch of cout statements. And the problem involves knowing how to use nesting of for loops. So we're going to have to use one for loop, the outer one, to determine how many lines get printed. And the inner for loop determines how many stars get printed on each line. So examine the following program and the output that's there, and then we'll talk about this. Notice the outer loop is easy. It just counts the number of rows that you want printed. You want 5 rows, it goes 5 times. The inner loop is where all the hard stuff happens, because this is where we have to produce stars for each row, and it's a different number of stars every time. We'll walk through this solution, but keep your eye on the condition in the inner for loop. J less than I. That's what really does this. This is an expanded version where you've got the 2 for loops and they've each got their curly braces all spread out, but as you can see, we didn't really need a lot of that to solve the problem. But it makes it much clearer, I think. You now know where the 2 nested structures are, and you can see the code and produce the output, and you might try this yourself. Go into Janus, type in the program, see what you can make it do. Okay, so here's the way it works. You've got 2 loop control variables, I and J. I for the outer loop, J for the inner loop. I is set to 0, and then we go into the inner loop. J is set to 0, and now we make an evaluation. Is J less than I? No, it's not. So the inner for loop actually doesn't run at all right now. All we do is go to the cout statement and print that, and it prints an empty line. Now we're done with one pass through the outer loop, so we go back up, we add 1 to I becomes 1. Now we drop into the inner loop, J starts at 0 again. 0 is less than 1, so we get to go in and print a star. Now we add 1 to J. 1 is not less than 1. J is not less than I. So the inner loop is over. We go to a new line. Then I gets set to 2. And now we drop into the inner loop, and you can see the process starts again. J goes to 0 and counts its way up to 2. When it's 0, we print a star. When it's 1, we print a star. When it's 2, Okay, it's no longer less than I, so it's time to leave. Then the outer loop kicks I up by 1, it's 3, and the inner loop counts its way up. 0, 1, 2, and then when it gets to 3, it's time to leave. And so we go back to the outer loop, I goes to 4, and then drop into the inner loop. J starts at 0 again, 0, 1, 2, 3, 4. And when it gets to the limit, then we go back to the outer loop, I gets set to 5, and now we're done with the outer loop. And that's produced that interesting pattern. It does take some thought, it takes a lot of attention to detail, but it's a very powerful tool. We'll find lots of algorithms that use nested for loops later on in the course. So this is an easy way to get into it. Now what if you wanted to do it so you didn't have that empty line at the top? So actually that had a star there. Okay. We'll have to make some modification to this particular bunch of code and to make that happen. And one modification might simply be to let J go up as long as J is less than or equal to I to have it print something. So now this inner loop is going to run more times than it used to. One more time than it used to. Also, to make our program truly generalizable, instead of using 5, we should use a value like n, so it can produce patterns that have 5 rows or 9 rows or 100 rows or whatever the user wants. They would enter n. Now consider what it would take to flip this output. Instead of starting low and going to a high number of stars, it starts high and goes low. How would we modify this code to pull that off? Well, one hint here is don't mess around with the outer loop. Leave that like it is. It still prints 5 lines. It's the inner loop we're going to have to look at. We're starting the inner loop at J and running up to I. And if I is low, that doesn't print very many stars. So the key to this is going to be the condition in the inner loop. Let's start J at whatever I is and run it up to n minus 1. So the first time through, I is set to 0. If n is 5, then J starts at 0 and counts its way up to 5, and the inner loop produces a bunch of stars. The next time around, I will be 1, and so we'll start at 1 and count to 5. The next time around, I will be 2, and so the inner loop will start at 2 and count to 5. So we're producing fewer and fewer stars each time. You could also do it this way. You could count backwards. Notice the J minus minus at the end of the for loop clause. We're starting J at a high number and counting down to I. And that works too. There's a variety of different solutions here. Now, a much more challenging one. You see the pattern at the top on the right hand side. We were able to produce that with the code that's there. What if we wanted to produce the pattern you see in blue on the lower right hand side? How would we do that? It's kind of shifting everything over. Well, the way to pull that off would be to print not just stars, but also spaces. And so you can see in this algorithm, down at step 3, when it comes to processing, we're going to print a bunch of blanks, a bunch of spaces first, and then a bunch of stars. The number of spaces we print will start out with a lot, 5 spaces, and then only 4, and then only 3, and then only 2, and then only 1. The number of stars we print will increase, 0, 1, 2, 3. So this is going to involve a little bit more forethought about how that inner loop is going to work. Again, the outer loop remains the same. We're just going to run this thing 5 times. But the inner loop is where we're going to have to figure out how many blanks to display and how many stars to display. And actually, this means we have to have 2 loops inside. One to print the blanks, one to print the stars. And you can see the code for these here. We've actually seen the code for both of these earlier, just in different contexts. The first one, J starts at a different value for I each time. When I is 0, it runs up to the height, so it's 5. The first iteration, next time we come around, it'll be 4 and 3 and 2. And that's spaces. The stars, on the other hand, J starts low, and we use I as its upper bound, so it doesn't print any stars first, and then it prints 1 the next time around, and 2, and so on. It's a tricky little program. It doesn't seem like it's all that difficult when you begin, but then it kind of takes off on you. But it's really interesting. On an exam, I oftentimes ask people to write code that will produce various patterns of stars to illustrate the fact that they know how to do nested for loops. So it's something you should play with. It can be a relatively easy example. It could be one like this. It looks easy but isn't. Okay, there's the code for that. Or it could be one like this that really looks difficult and in fact just builds on some of the pieces we had before. All kinds of things can happen. There's an infinite number of patterns of stars that you could be asked to produce. But again, I won't ask this on the first exam. I will ask this something like this on the second exam or on the final. So you should know how to do nested for loops. For now, it's probably instructive just to have seen these examples and know where this might go, and maybe try 1 or 2 of the simpler ones out yourself. Just log on to Janus and just kind of tinker around with it and see what you can make it do. But that's nested for loops. There are many, many ways that we will see nested for loops in the coming weeks. So this just kind of cracks open the box on that. Okay, thank you for watching.